Greetings, geometry students. Oh, hey, greetings, geometry students. If you notice behind me, there are no crutches. So, yay! It's my birthday. I have no crutches. It actually really is my birthday, so happy birthday to me. I don't have to wear my crutches. I have to wear the boot to walk around, but I'm a little slower, but I'm under my own power. So, yes, I feel like a person again. So, let's get started. I do need to apologize. I cannot believe in the last video that I did not use cubic units for volume. I'm just cringing here. So please accept my apology. I cannot believe that. So volume. Volume of a pyramid is going to be 1/3 base times height. But again, this is not base. It's a little b. This is area of the base. Okay, so area of the base multiplied by the height. So area is a squared unit multiplied by height. That's going to be a squared unit multiplied by another 1 unit, so you give you a cubic unit. Volume of a cone is going to be 1/3 area of the base multiplied by the height. But we can simplify this because we know the base is going to be a circle. So a circle is pi r squared. So r squared, so let's say that's inches squared, multiply the height in inches, so that'd be inches squared times inches, be inches cubed. So cannot overemphasize that. So with volume, with surface area it did, but with volume it doesn't matter if it's an oblique cone or pyramid. So as long as you have the height and in the base here, you could take area of the base multiplied by the height, and you would get volume. So it doesn't matter if it's oblique with volume. Okay, so let's start a problem like this. This is like, say you took you had a birthday party and you wanted to take 2 party cones and just put them together. Okay, and so you put them together, you're wearing them on your ears or something. But and then you find the volume that's in between here. Probably for some of us like me, it's not a whole lot. No, just kidding. So we want the volume, okay, of this empty space in here. Okay, so how do we do that? Well, again, area the base, even though there is no base, but the base for both of these is going to be the same. There's no physical base I could touch, because if a party had, so it'd be open space, but we want all the open space in between. Okay, so whoa, a lot of here going on here, but this, guys, again, I can't emphasize, this is the magic step right for here. This step for me is gravy. All right, it's saying total volume, even you can have T or tote. Okay, total volume here is volume of cone 1 plus volume of cone 2. Okay, next I'm showing my equations. Subscripts, if you want to pursue upper level math, subscripts are your friends. So 1/3 pi r squared. The radius for both of these is the same. Both of them are 10 times height 1. Okay, times height 1, and then it says 1/3 pi r squared times height 2. Okay, then I plug in the parts where they belong. I included the units this time because I was kind of scared I'm just going to do something crazy like not do meters, millimeters cubed for volume. All right. Put all those parts in, and then booyah, I have the volume of this figure. I'm gonna go ahead and do surface area. I'm gonna do volume. I'm gonna do one more example, but so that's really the final thing. I'll give you a figure like this on a test, and the test is gonna be a little bit different. It's gonna be something like this, like 6 problems or so, and I'll ask for volume and surface area. So what is the surface area of this figure? So let's set it up. Okay, so if I were looking at this thing, the surface area here would be the lateral surface area and the lateral surface area. So it'd be, we don't have to find the area of the base because we can't touch the base inside here. So it's just lateral surface area of cone 1 and lateral surface area of cone 2. Okay, so again, looking at surface area, lateral surface area cone 1 plus lateral surface area cone 2. Remember, surface area of a cone is 1/2 circumference times the slant height. Guys, on the quiz that we just took, several of you used the height that was given and not the slant height. Okay, So I broke this down to 1/2 times 2 pi r, that's circumference, times L1 plus 1/2 2 pi r times L2. The equation can simplify to pi r L because the 1/2 times 2 goes bye-bye. Okay, so put one there. Okay, slant height, remember, is this. Slant height is this. This is height, the 90 degrees height of the cone, but slant height is this. Okay, so down here I need the slant height. I just made some little triangles. 18 to, we know that's a right angle, so we can find the hypotenuse of both of these. So 20 squared plus 10 squared equals L1. I'll put L1, L2. Okay, so I want this and I want this. So booyah, rounding to the tens place. And then after that, I'm going to just plug those parts in and I get the total. Okay, so not to make the boo-boo today, I'm making sure that I provide units. So I put millimeters times millimeters is millimeters squared, and then millimeters times millimeters is millimeters squared. It's like algebra, x squared plus x squared is 2x squared. Okay, so really I'm just taking this value and then I'm adding this value with units. It would be like x squared plus x squared, or 10x squared plus 20x squared would be 22x squared. Alright, so the units won't change because there's an addition in between here. But millimeters, millimeters, millimeters squared. I still okay, so we're going to do one more. Alright, in the space provided. Here we go. Okay, so this last one is this one. Sorry, it's a little messed up there. Okay, not the best drawing. This is number 25 in your book. Okay, so number 25 in your book. The radius is going to be this, and the height is this. We're going to do both surface area and volume. Okay, so first off, it's like, wait a second, how do we do this? What is the volume? Okay, well, this isn't a empty space. This is a hexagonal base pyramid, okay, and it's inverted in a cylinder. So this is empty space, okay. This I could touch. This is solid space. So we want the volume of the solid. So in order to find the volume of the solid, we have to find the volume of what's solid. And so what's solid here is going to be, so I'm going to touch, I'm going to touch this, or how much there is. We have to subtract out this empty space, okay? Different than this one, here I wanted to know how much this was. Well, we don't know if that's solid or empty in this one, but we wanted to know how much. Yeah, I was struggling there. So the volume, again, going back to the definition, that's always a good idea. The number of cubic units contained in its interior. Okay, so this is the interior of it. Now, this doesn't exist because that's empty space of that figure. All right. So if it has like a divot in it, I mean, for example, if I had let me draw something real quick. Drawing that like super crazy quick. This is empty space. My point is, you wouldn't call this and fill this in if you were finding the volume of this. You wouldn't say, oh, this would be, say these are all blocks here, and they're all 1 cubic unit. All right. You wouldn't go 1, 2, 3, 4, 5, and then go add another 6. You wouldn't do that. Okay, that's the same idea here. You wouldn't go and add extra volume here to this empty space. Okay, so let's work it. How do we do this? Well, this is going to be the volume of the cylinder minus the volume of the hexagonal pyramid. So the volume of the cylinder minus volume pyramid. Area of the base of the cylinder times the height, minus 1/3 base of the pyramid times the height. Height for both of them are the same. Okay, that's why it's this. Pi r squared h, no problem. 1/3 times 1/2 ANS. I know you guys use P sometimes. I like ANS, so it makes me make sure I get all the parts times height. Okay, so problem. We got to find A and we got to find S. So again, from up here, the radius, this is touching this edge. So if I were to draw it to the center of the circle and go there, that is the radius of the cylinder. So it touches the circle and goes all the way to the center. So that would be the radius. Kind of taking that and move that over here. So if I'm looking at the top-down view of my, I kept saying hexagon. I'm sorry, octagon. I think I'm not going to rewind and relook at it, but I think I kept saying hexagon. Hello, it's an octagon. 8-sided figure is an octagon, not a hexagon. So my apologies again. Again, if we were in class together, you would say, don't you mean octagon? And I hope that's what you do. All right. So we have an octagon here, and so from the center out, that's radius. Okay. We know that this angle connecting these forms a triangle. Okay. This is a 45-degree angle. How did I get that? I took 360 divided by 8. Okay. 360 divided by 8 is 45 degrees, and then I take that angle and I'm going to cut that in half because I need the apothem. Alright, and I'm going to just, this is all review, so I shouldn't have, we did this in last chapter. Okay, so found the apothem, found the half of the side length, had to double this. This is not the side length, this is only half of the side length, had to double it. So it looks a little messy here, but following this, pi radius squared, height to 1/3, 1/2. 1.85 is the apothem, 8 sides, side length is doubled this number here, and then 3. Units were kept in this one, yards squared, yards, so yards cubed, yards, 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 yards cubed. Subtracting these two, we get 26.3. Okay, let's do surface area. Okay, so this is how I want you to start thinking. Okay, so if I want the lateral surface area, alright, that's going to be the bottom, okay? This is all the regions I can touch, the bottom. Then we've got this. We've got the outside of the cylinder. Then we can touch the sides in here, so we can touch those. That's the lateral surface area of the pyramid. So I've got the bottom, which is the circle. Got the lateral of the cylinder, the outside. I could even write outside here. Outside. Okay. And I can write inside. Okay, this is kind of how you want to think. Bottom, outside, inside. This really helps to kind of break them down into parts. What's the area of the bottom? Bottom's a circle, pi r squared. What's the area of the outside? The outside's a cylinder, the lateral surface area of a cylinder, so it's going to be 2 pi r h. And then what's the inside? The inside's a pyramid, all right, so it's going to be 1/2 perimeter times slant height. So we still got to get, the last thing we've got to get that we're missing is the slant height. Okay, so boom, let me show. So there's a lateral. So this is, if I take this, 2, let me use small. So 2 yards out here is the radius, and then the height. And so the slant height's going to be form a right triangle here. And then I'm going to use Pythagorean theorem, 3 squared plus 2 squared. Take square root, approximate 3.6. Okay. So now I plug in all my parts. Boom, 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 boom. The radius 2, height is 3, and then on this one the perimeter 1/2 times the side length, or number of sides, multiplied by the side length. We got that earlier, so that's nice. That's why, hey, that's why I put them together. So we are often will find some of the information we already need. Multiply by that, adding all the parts. Yards squared, volume cube, area squared. Okay. For homework, I'm gonna have special instructions right now. I have 1 minute. I think I'm gonna assign like 3 problems, okay? But special instructions are, you need to find the volume and the surface area, okay? So if I have several students that are not watching the videos to help out, so please, as part of your homework is watching the video. So I'm gonna assign only a few problems. I want you to do both. I want to find volume and surface area. Okay? Alright. So, y'all have a wonderful day and God bless. Okay. Alright, bye.